Hi, everyone. This is Judy with Altium's OnTrack podcast. Thanks again for joining us. You'll see that we have a familiar face joining us, and I have some exciting news, is that Chris Hunrath will be one of our presenters at Altium Live in October in San Diego, so I hope you'll be able to join us. Registration is now open. And pretty soon we'll have Chris's topic up. We haven't decided exactly what that'll be, but as soon as we do, we'll make sure and let you know. Remember, you can always connect with Altium on the usual social media channels, and remember, we're also on YouTube. And today we are going to talk about hybrid construction. So Chris called me actually because he was at Division of Raytheon and had just listened to the Rick Hartley podcast about inductance and plane inductance. And so we wanted to kind of follow up on that, and I wanted to hear a little bit about what Chris is sort of seeing as trends in the marketplace relative to hybrid construction. So Chris, welcome back. Thanks for joining us again, and we look forward to hearing from you.
Thanks, Judy. Yeah, so we were actually discussing embedded capacitors, which in PCB is typically done with very thin dielectric planes. You can get different levels of capacitance depending on the thickness or the thinness of the dielectric, and also the dielectric constant of the dielectric. But one of the things that you don't get from embedded capacitor material or planar capacitor materials is high capacitance. So an individual component will give you a very, very high, relatively high capacitance level. Actually, there's a capacitor shortage right now, but that's a whole other subject.
Yeah.
There's a desire to remove surface capacitors, decoupling and bypass capacitors, for a lot of different reasons. You get rid of the vias, you get rid of the via inductance, you increase the circuit density because now those via locations are available throughout circuits. But one of the things that a lot of people don't or aren't familiar with embedded capacitor materials, even though the capacitance per square inch is small, you don't need as high a capacitance in that case because you're getting rid of a lot of the in-plane inductance. And that's exactly what Rick talked about in his podcast. He used a 4-layer example, which I thought was really great because it really boils it down to the simple.
Right.
You have a 4-layer board. Why would you use a thick core and then build out from layer 2, 3? People do it because it's easy, and it used to be I say used to. When we built thicker multi-layer boards and had fewer numbers of layers, those thicker building blocks were very commonplace. It's a lot more common now to have much thinner materials. But as he pointed out, why not go thinner, and reduce your in-plane inductance? And again, we were there to discuss getting rid of surface capacitors by reducing the in-plane inductance. And you can eliminate a large percentage of the capacitors, between 40 and 60%, both by using the capacitance of the planes and also reducing the in-plane inductance. In this case, we were talking about a polyimide film that's typically used for flex circuits, mm-hmm. which can be used in a rigid board as a thin dielectric layer. Polyimide film's nice because it's got very high dielectric withstanding voltage, and you can make it really thin. So you can build it into a rigid board and get the properties you need to get rid of those capacitors. But that also leads into hybrid constructions. Now we're mixing materials. You might have FR4 and polyimide film. How do you process them? The building blocks used to make flex circuits, if you're using an acrylic, which I talked about in the previous podcast, uh-huh. It laminates at standard FR4 temperatures. Polyimide films, true polyimide films, laminate at much higher temperatures, like 600F. You can't do that with FR4. You can't expose it to those temperatures.
Right.
So you would use, in the case of buried capacitance materials, you would use the FR4 as the glue, and you would just use the core, the polyimide film core as is. You would print and etch it, bond treat it, and then build it into your FR4 part. It gets a little more complicated when you start.
Can you clarify? I want to stop you there for a minute. When you say you use the FR4 as the glue, explain that. I'm having a little trouble visualizing that.
Okay. So in a standard multi-layer, you would use a combination of epoxy-coated prepregs
Right.
and cores.
Yep.
And the prepreg is basically the glue.
Yep.
You would print etch the core, you would laminate it all together. The prepreg would melt, flow, cross-link. It's a thermoset, and then you would drill and plate. The plating links everything in the z-axis. Whether it's vias or component holes. In the case of a material like, and it happens to be DuPont's material called Intera HKO4, which is basically it's Kapton based material, polyimide film based. You would use prepreg against it to bond it into the system. You wouldn't use a polyimide film.
I see. Okay.
So in RF designs, the same is true with PTFE materials. You wouldn't use PTFE films, FEP, or some filled ceramic filled PTFE bond sheet in an FR4 build, a hybrid build, because the FR4 can't handle the temperatures that you would need to laminate it. So if you do use an RF material in an FR4 build, you would use the prepreg, FR4 prepreg as the glue, or the epoxy prepreg as the glue to build the system. Now that limits what you can do. With that kind of a build.
So is it just the B stage? I know you need to match basically the B stage to the property of the material that's adjacent generally. So does that mean, is the heat problem sort of in the B stage or in the material itself?
Well, it's a manufacturing problem. So the temperatures required to melt, flow, fill, cross-link in some cases, PTFE is a thermoplastic.
Yeah.
That's done at high temperatures. So in building the multi-layer is where the issue becomes, or the issue exists.
Okay.
When you laminate that all together, the FR4 would be broken down, overcured basically. It would start undergoing decomposition at those times and temperatures to laminate that. So you can use a PTFE based material as a cap layer, but you couldn't use it anything.
Okay.
You'd be restricted to one layer deep on each side.
I get it now.
You couldn't go any further. Now we've been marketing some newer materials from Isola that have Teflon-like properties, but they laminate at normal temperatures.
Which is awesome.
Well, so now you could do an RF foil construction, where before you'd be limited to a cap construction. And so for people doing designs, they want to connect layer 2 to 3 with a blind plated via, and then do a foil lamination for the RF layer. Now that's a viable option.
That's pretty awesome.
Yeah, it's something that's gaining a lot of interest, and it's a growth area for us. And we have products in the mid 3 DK range, and products in the 3.0 high 2s, low 3 range. So that just opens up some opportunities to make some different designs. But one thing that designers should be aware of is you can't mix B stages in the same spot. So even if the lamination temperatures are compatible, you wouldn't want to mix, let's say, a PTFE material and an FR4 material. Well, those you can't laminate anyway. But you wouldn't want to mix, let's say, a PPO-based resin and an epoxy-based resin in the same opening. So if you were to, laminate, let's just say, layers 4 and 5 together in a multi-layer build, you wouldn't put both prepregs in that same opening. Now, if the lamination temperatures are compatible, you could put them on different layers. In other words, use one type of material, let's say the PPO-based resin, between 4-5 and epoxy-based material between layer 6-7, and that wouldn't be an issue. Again, as long as the lamination temperatures are compatible. And again, that just opens up designs. Why do people mix materials? So people want the economy of FR4, but they need that very specialized RF layer. In some cases, they're mixing high-speed digital and RF, and a lot of RF materials don't come in the variety of thicknesses. Talking about the cores and prepregs, they don't come in the variety of thicknesses the RF that HSD materials or high-speed digital materials come in. So if you wanted to do some different things in the high-speed digital side, but also have the RF properties, you're going to want to be able to mix those materials. So it's just something that's becoming very, very popular.
It's just amazing because I've worked with hybrid constructions before, but it just sounds like it's becoming more of like, I don't know, like gourmet cooking, like mixing all these, wide variety, of things together. Plus new materials are becoming available, which is exciting because, again, it's like new media, for a designer that you can work with and work around to get the performance you want. So it's pretty cool to hear about.
It is becoming a materials science-based business because there's lots of different things. I talked about OrMed in a previous podcast.
Yeah, I was going to ask you about that. You'd mentioned that people are embedding components. So tell us about that.
Yeah. So components you would normally use on the surface of the PCB, they're being put inside.
Right.
Now they'd have to survive the lamination temperatures.
Mm-hmm.
Nice thing and you could in theory do that with solder paste. The downside of using solder paste is when you go through reflow, that interconnect inside the PCB may also reflow, which you really don't want. You really don't want that. So because the OrMed's a non-reversible reflow or sintering, once you've sintered the capacitor, in this case the surface mount capacitor, to the inner layer, it's not going to melt again. It won't melt again if you're doing subsequent laminations, and it won't melt again during assembly. So it's kind of locked in place both electrically and mechanically. So again, as long as the component, so there's there's some materials allow you to do things you couldn't do before. I've helped customers with coin embedded coins, also using the OrMed paste, in a similar fashion. Making connections to an inner layer with the paste and then embedding that in the PCB.
And the coins are just for heat sinking purposes, correct?
Sometimes they can be used for other things as well.
What else are they used for?
You could use them if you wanted inductance, you could use them for that purpose. Yeah.
Okay.
Yeah. So there's just like you can make a heater out of just running a copper trace in a particular fashion. You wouldn't normally want to generate heat on a copper trace, but if that were your goal, you could do it.
Huh. Interesting.
One of the things too, we talked about bleeding some printed electronic technology into PCBs. I've been involved in some conversations with DuPont. They have a very interesting liquid polyimide technology that cures at 300 Fahrenheit, which is very low. And we're exploring the opportunity to use that in lieu of solder mask, because solder mask on the surface is becoming an issue. Its loss characteristics are not great. It's an epoxy.
Not.
Yeah, it's an epoxy acrylic hybrid, and it doesn't have great loss characteristics. So people are looking at surface finishes to replace the solder mask, but they have their issues. Of course, nickel gold has their problems, right, with the nickel. And then, of course, immersion silver, it tarnishes, it's very fragile. Some people are worried about whisker growth. So, could we put a liquid polyimide on the surface that has, a loss characteristic of maybe 0.003, dielectric constant of 3.0, and, now it's not so bad, and it's protecting circuits from...
How would that be applied?
You would screen it on.
Really? That's cool.
Unfortunately, turning it into a photo-imageable product has some technical challenges, not the least of which is increasing the loss, which is kind of defeats the purpose of doing that, right?
Right.
So the downside is it has to be screened on. But, of course, screening has come a long way. In the print electronics world, people are they're screening 100-micron features. So, you could do some pretty good things with you'd have to have someone who's experienced in doing that, but it does open up some options.
Man, whenever I talk to you, I'm just always like, I was talking to Dwayne Benson from Screaming Circus recently, and I was telling him about the experience that I left the industry for 12 years and came back, and I knew it was going to be like drinking from the fire hose, but I told him I they have a Screaming Circuits, does these crazy quick turn, a push of a button. Screaming fast.
Yeah.
And so they, I was telling him, I feel like Rip Van Winkle when I came back, and he goes, Judy, I feel like Rip Van Winkle every Monday. That's how I feel when I talk to you, Chris. Like, I'm like, wait, when did that happen?
I'll tell you, it's been a crazy 30 days. There's so many good opportunities.
Wow.
And so many different designs, and and people are hungry for the information, so we're just trying to help.
Yeah, well, thanks so much for getting this out and teaching me along with our listeners. So as far Chris and I spoke right before we recorded this, and he sent over a slide deck regarding the embedding components with the ORMET, right, Chris? That's what you sent over?
Yes.
And we'll make sure we'll attach that to the link to the show notes or PDF or however we'll get it in there for you so that you guys can see it visually and, be like me and just try to keep up. So is there anything else we needed to cover before I let you go? I know you're on your way vacation.
Yeah. Not that I can think of, but if someone needs information on hybrid constructions or sintering paste, if they, if you guys can include my email information, that'd be great. So.
Okay. Yeah, we'll do that.
Okay.
Careful what you wish for. Perfect timing. We'll give them your email right before you go on vacation. So have fun diving in North Carolina.
Thank you.
I'm not jealous at all. Well,
you're in a beautiful place for scuba. You're in San Diego.
I know.
La Jolla is awesome.
If I just stop podcasting and working all day, dang it. But I'll get there. Vacation's coming.
You can dive with the electric rays and the leopard sharks.
I know. Okay. All right.
Anyway.
Hashtag goals. Okay, so thanks again, Chris. Have a great time on vacation, and we'll talk to you soon. And we're looking forward to also your presentation at Altium Live, so thanks for agreeing to do that.
You're welcome. Sounds great.
Okay, so thanks again for joining the OnTrack podcast. We look forward to seeing you next time. Until then, remember to always stay on track.